Hey guys, I am Suthar. Welcome to my channel. My last video being so long, so I make this video. Actually, this video is part second of that video. Okay, and today the topic is electrocyclic ring opening reactions. Okay, and in my last video the topic is ring closing reactions. Okay, so let's go on our topic, electrocyclic ring opening reactions. So we discuss on basic point of what is a electrocyclic ring opening reactions. Okay, so any closed ring systems undergo ring opening either by these conrotations or by these disrotations. Okay, in presence of heat or light to form a chain conjugated product. Okay, this type of reactions are called as a electrocyclic ring opening reactions. Okay, and I just use a term closed ring system. So questions arise, what is a closed ring system? Okay, any cyclic system having two sp3 hybridized carbon atom are called as a closed ring system. Okay, so what is a closed ring system? So any cyclic system having two sp3 hybridized carbon atom are called as a closed ring systems, and closed ring systems are formed ring opening reactions. Okay, so let's take an example for this closed ring system. First example is a cyclobutene. Cyclobutene having two sp3 hybridized carbon atom and two sp2 hybridized carbon atom. So this cyclic system is a closed ring system, and it's form ring opening reaction. It's participate in electrocyclic ring opening reactions. Okay, and it's named as a 4 pi electron system, closed 4 pi electron system, because it's formed by 1,3-butadiene and 1,3-butadiene having 2 pi bonds. It means 4 pi electrons. Okay, so its name is open 4 pi electron system, and its name is a closed 4 pi electron system. So different is as a prefix closed, as a prefix open. Okay, in this open chain we use prefix open, and in this closed chain, in this closed cyclic system we use prefix as a closed. Okay, so next example is cyclohexadiene. Cyclohexadiene having two sp3 hybridized carbon atom. So this is also example of closed ring system. It's closed ring system and it's from electrocyclic ring opening reactions. Okay, second example. And third example is a cyclohexene. Cyclohexene having four sp3 hybridized carbon atom. So it's not example of closed ring system. Okay, so this is not example of closed ring system. It's example of closed ring system, and it's also example of closed ring system, and it's named as 2 pi bonds. It means 4 pi electrons, and it's formed by the 1,3,5 hexatriene. So it's a closed 6 pi electron system. Okay, yeah. Next example is a cyclopentene. Okay, cyclopentadiene, right? And other is a cyclopentene. Okay, cyclopentadiene having one sp3 hybridized carbon atom, so it's also not example of closed ring system. Okay, and cyclopentene having 3 sp3 hybridized carbon atom, so it's also not form closed ring system, also not example of closed ring systems. Okay, next example is a okay, there is a 2 sp3 hybridized carbon atom, so it's also example of closed ring system. Okay, and it's form electrocyclic ring opening reactions. It does not form electrocyclic ring opening reactions. Both of one does not form ring opening reactions. Okay, this is an example of closed ring system. Okay, and next important thing is a stereoselectivity. So what is a stereoselectivity? Okay. Second important thing point is the stereoselectivity. So what is a stereoselectivity? Okay, in this electrocyclic reactions, a substrate molecule can be opened by this conrotations or by this disrotation. Okay, and it's depend on this reactions, and each of conrotation and disrotations have two mode of rotations, which are inward mode of rotations and outward mode of rotations. Okay, so first is a inward mode of rotation, and second is a outward mode of rotations. Okay, so what is the inward mode of rotations and what is the outward mode of rotations? Okay, so let's discuss inward mode of rotations. If the substituent group are migrate toward the cavity of substrate molecule, this type of rotations are called as the inward mode of rotations. Okay, so substituent group migrate toward cavity of substrate molecule. Okay, substituent group migrate toward cavity of substrate molecule. This type of rotations are called as the inward mode of rotations. Okay, so what is the outward mode of rotations? It's opposite to inward mode of rotations. If the substituent group are migrate away from cavity of substrate molecule, this type of rotations are called as the outward mode of rotations. Okay, so substituent group migrate away from cavity of substrate molecule. Okay, this type of rotations are called as the outward mode of rotation. Okay, let's explain with this example. Okay, so first example is both of our conrotation and disrotations take place. Okay, so Okay, so if their conrotations are occur, if their disrotations are occur, if their conrotations are occur, if their disrotations are occur. Okay, so what is the inward mode of rotations and conrotations? Okay, so substrate molecular, it means there are methyl group. You can see there is a conrotation. Conrotation, it means C2 axis of symmetry. So if methyl group are here, so other methyl group are here. Okay, and their hydrogen and their hydrogen. Okay, their disrotation, it means mirror plane of symmetry, and mirror plane of symmetry, one methyl group are here, so other methyl group are here, and hydrogen are here, and hydrogen are here. Similarly, conrotation, methyl group are here, methyl group are here. Disrotation, methyl group are here, methyl group are here, hydrogen here, hydrogen, hydrogen, and hydrogen. So what's the difference between inward mode of rotations, con-inward mode of rotation, and con-outward mode of rotation? Okay, so different is migrate toward cavity and migrate away from cavity. Okay, in this inward mode of rotations is occur by toward cavity, and in this rotations are occur away from cavity, and cavity are here. These are cavity. Okay, so in this inward mode of rotations, the substituent group are migrate toward cavity. Okay, toward cavity, it means if this substituent are migrate clockwise, in this con rotations, it's also rotation in clockwise. Okay, so this type of rotations are called as a con inward mode of rotations, and in the con outward mode of rotations, the substituent group are migrate away from cavity. It means if these are rotate in anti-clockwise, so these are also rotate in anti-clockwise. Okay, this type of rotations are called as a con outward mode of rotations. Okay, yeah. And what is a dis inward mode of rotation, and what is a dis outward mode of rotation? Okay, so this, it means both of our rotations are opposite to each other. If this methyl group are rotation in clockwise, this rotation in clockwise, so it's also rotates in anti-clockwise. Okay, both of are opposite to each other. Okay, but both of are migrate toward the cavity, so this type of rotations are called as a dis inward mode of rotation, and in this case both of are rotate away from the cavity. Okay, if these are rotate anti-clockwise, so these are rotate clockwise. Okay, so both of our methyl group away toward the cavity, so these rotations are called as a dis inward mode of rotation, and these are called as a dis outward mode of rotation. Okay, so this difference between the inward mode of rotation and outward mode of rotation. Okay, and some groups are here which are given inward mode of rotations. That is a two kind of groups. Strong, first strong group, and second is a weak group. Okay, strong group is a OH group, NH2 group, fluorine, and any alkene. Okay, and weak group is a COCH3, COOR, CONH2, phenyl group, chlorine, bromine, and iodine. Okay, and in the case of presence of Lewis acid, inward mode of rotations are outward mode of rotations are act as a inward mode of rotation. Okay, these are groups given outward mode of rotations. Okay, and in the case of presence of Lewis acid, outward mode of rotations group are act as a inward mode of rotations. Okay, yeah, let's take example of inward mode of rotations and outward mode of rotations. And the substrate molecule prefer one type of mode. This type of selectivity are called as a stereoselectivity. Okay, so let's take an example first. This example is clear out difference between the outward mode of rotations and inward mode of rotations. Okay. The reactions are take place by heat, and this 4 pi electron system heat, so cone rotations are occur. Okay, so cone rotations are occur. Okay, and psi 2 is a high occupied molecular orbital, and there also psi 2 is a high occupied molecular orbital. Okay, so in these reactions, if we take by outward mode of rotation, and in these reactions if we take inward mode of rotations. Okay, we will see what's different in this product of outward mode of rotations and inward mode of rotations. Okay, so let's take an example. It can be also represent as this type. There is methyl substituent, and there also methyl substituent. Okay, so outward mode of rotations, okay, and inward mode of rotations. Okay, outward mode of rotation, it means the substituent group are migrate away from the cavity. Okay, so if these are methyl group are rotation in anti-clockwise, so these are also anti-clockwise. Okay, so in this case positive pole upside, and in this case negative pole upside, and methyl group are here and a methyl group are here. Okay, so product is this type, so positive up pole negative, and negative up pole and they are positive. Methyl group are here, and in this case methyl group are here. Okay, yeah, and you can understand by this trick. We discuss on my last video. Trick is that OCT, ODC, SCC, SDT. This trick are used for the ring closing system. If you want this trick used in ring opening system, we will read backside. Okay, we will read backside. Yeah, because the reactant in this trans or cis form, and there is a trans and cis form. Okay, and we will get product opposite direction of substituent and same direction of substituent. Okay, so this reactant is in this transform and conrotations, transform and conrotation, transform and disrotation. So for these reactions, this is transform and conrotations. So product is in opposite directions. So you can see their methyl and their methyl, both of are in this opposite direction. Okay, so it's solved also by this trick. Okay, and in this reactions, if we rotation in con inward mode of rotation, it means inward, it means toward the cavity. Okay, if this methyl group are rotated in these directions, okay, and con rotation occur, so this methyl group are also rotated in same directions. Okay, both of are in same directions. Okay, so the product is negative sign up pole and there positive sign up pole, negative sign here. Methyl group are here and this methyl group are here. It's also opposite directions of substituent. So opposite direction of substituent. So it's difference between the con outward mode of rotations and con inward mode of rotations. Okay. Yeah. Take one more example. So in this example, we can see two type of reactions: con outward mode of rotations and con inward mode of rotations. Okay. So what is the con outward mode of rotations? Outward mode of rotation, it means the substituent group are migrate away from the cavity of substrate molecular. Okay, this is a cavity of substrate molecular. It means this fluorine substituent are migrate anti-clockwise. Okay, so due to the con rotations, this fluorine substituent are also migrate anti-clockwise. Okay, so formations of product are fluorine are here, CHO are here. Okay, so double bond, there fluorine and CHO, there is fluorine and this CHO are here, fluorine are here and CHO are here. Okay, and in these reactions, inward mode of rotations are take place in these reactions. Inward mode of rotation, it means the substituent group are migrate toward the cavity of substrate molecular. Okay, it means this fluorine this substituent group are migrate toward the cavity of substrate. It means clockwise. So due to the con rotation, similarly this fluorine also rotate in clockwise. Okay, so it's also rotation in clockwise. So formations of product are fluorine. Okay, this fluorine are there, CHO are here, and fluorine and CHO. Okay, so now you can see the difference between the con outward mode of rotations and con inward mode of rotations by this example. Okay, and if you can't see my last video, the link are provided in the description box. You can see. Okay, and thank you for watching this video. Like, share and comment and subscribe me. Okay, thank you.